As of now, we know about the existence of 118 elements. Most of them are found on the Earth either in free state or in combined state in the form of minerals. But the elements having atomic number greater than 92 are man-made. Till 1860s, only 63 elements were discovered. In order to understand the properties of these elements, the scientists of that time tried to classify the elements on the basis of similarities in their properties. The first successful classification of 63 elements known at that time was given by Dmitry Mendeleev. He prepared a card for each element, citing its symbol along with some physical and chemical properties of that element. Then, he arranged all the cards in increasing order of atomic masses. While doing so, he noticed a pattern in some of their properties. For example, he noticed that as atomic mass increases, the number of chemical bonds formed by that element also increases up to a certain point and then it decreases again. This pattern repeats throughout. Mendeleev called these repeated patterns as periods. He arranged these periods into groups or columns. The elements placed in the same group had similar properties. For example, all the elements of group 1 are metals, except hydrogen, and form one chemical bond. All the elements of group 2 are also metals, but form two bonds, and this goes on. By arranging the cards like this, certain gaps appeared. Mendeleev proposed that the elements not yet discovered would fill these gaps in future. Features of original Mendeleev's periodic table. Mendeleev's periodic table comprises of horizontal rows and vertical columns. Vertical columns are called groups and horizontal columns are called periods. Groups. The groups in Mendeleev's periodic table are numbered from 1 to 8. Group 1 to 7 are subdivided into A and B subgroups. But Group 8 has no subgroups. Group 8 is subdivided into 3 rows, each containing 3 elements. All the elements placed in a particular group are chemically similar in nature and show regular gradation in their physical properties and chemical reactivities. Periods. In Mendeleev's periodic table, the periods are numbered from 1 to 12. However, the properties of elements in a particular period show regular gradation on moving from left to right. Modified version of Mendeleev's periodic table. In the modified version, the number of periods was decreased from 12 to 7, while the number of groups remained same. Noble gases were placed in the table as a separate group, called the zero group, without disturbing rest of the elements. Merits of Mendeleev's periodic table. Mendeleev's periodic table was the first successful attempt that included all the elements known at that time. The gaps left by Mendeleev in his periodic table motivated scientists to discover new elements. Astonishingly, when the elements were discovered, their properties were found to be similar as predicted by Mendeleev. He proposed the properties of 3 elements named as Eka silicon, Eka aluminium, and Eka boron, which were later discovered as germanium, gallium, and scandium. The properties of these elements were found to be much similar to Mendeleev's predictions. His periodic table proved similarities and regular variations vertically, horizontally in the properties of elements. Mendeleev was so sure about his periodic law that he ignored the law of increasing atomic weights, assuming that the atomic weight might not be correct. Therefore, he placed the elements with similar properties together. For example, cobalt, atomic mass 58.9, appeared before nickel. Atomic mass 58.7. Demerits of Mendeleev's periodic table. Positions of isotopes could not be explained. If one follows Mendeleev's periodic law, then the isotopes of same element should occupy different places. For example, the isotopes of hydrogen show same chemical properties, but according to Mendeleev's periodic law, they should occupy separate places in his periodic table, but it was not done so. The position of hydrogen was uncertain. Hydrogen resembles halogens of group 7 as well as alkali metals of group 1. So, its position in that periodic table remained uncertain. Chemically dissimilar elements were placed in same group. For example, highly reactive alkali metals are placed along with highly unreactive coinage metals in the same group. Chemically similar elements were placed at different positions. For example, copper, mercury, silver, barium, etc. were scattered all over the periodic table despite having similarities in properties. Despite these problems, Mendeleev's contributions made the task of understanding the properties of elements very easy for us. To honor his work, the element with atomic number 101 is named Mendelevium. The scientists acknowledged Mendeleev's work by installing his statue and his periodic table on the giant wall in St. Petersburg. Since some properties like atomic number were not understood at that time, some radical mistakes were left in Mendeleev's periodic table. These were corrected later in the modern periodic table. Although the modern periodic table looks different, but it also has periods and groups as Mendeleev proposed long back.